Step number 1, we start with the vertical asymptotes. How do we find vertical asymptotes? Oh, I should put slash holes, because it could be either or. So how do we find vertical asymptotes or holes?
You factor.
Good morning. You are very colorful. I love it.
If it cancels, it's a hole, and if not, then you set all of the parts of the bottom equal to 0.
I'm just writing down what you're telling me, by the way. I'm just going to grab red, if I can find it, because this is the one thing we haven't talked about yet. If it's a hole, you have to find the y coordinate, because you need to know where to plot the hole. And this was in the homework yesterday, so we'll see who actually got through the homework. How do we find the y coordinate? Yeah, how do we find the y coordinate? Sorry, a little bit louder, Noah? That'll just give you the x-intercept, but you don't know that's where the hole necessarily is. Yep, so substitute the value. And solve for y. Okay, so you can always put any x value into the equation and get the corresponding y. We're just picking the hole specifically so that we know where it is. So once we're done with our holes or our vertical asymptotes, we go to the horizontal / oblique. Three cases. So degree over degree plus 1, degree over degree, degree plus 1 over degree. This one is your y equal to 0, or I should say it's not equal to 0. Second one, we call it a over b. If that doesn't mean anything to you, then write the leading coefficients, whatever makes sense to you. But this is where we divide the two coefficients to get the value. And the third one is our synthetic division. I forgot the N in there. Synthetic division. What does synthetic mean, by the way? Fake, yeah, so it's fake division because we're doing it upside down and we're just using the coefficients. And step number 3 is the intercepts. How do we find an x-intercept? And clearly the other one's the reverse. The y-intercept is x equal to 0. So the last thing, and this is going to make sense once we do the example, but use test points to determine the shape. Jen, I can't look at you without laughing. It's awesome. And what test points means is that you pick appropriate x values, and I'll tell you what appropriate means when we get down to an example. Substitute them in the equation to get the y value. So exactly what you would do with the whole. Pick various x values, substitute in to get the y coordinate. So substitute appropriate x values. and no, I said substitute, and solve for y. Okay, so let's take everything we've done the last 2 days and let's actually graph an example. Bless you. Was that Rob? Step number 1. Find the vertical asymptotes or holes, so we're going to factor anything we can. We can take out a 2 on the top. Can we factor on the bottom anything? Okay, conclusion. Okay, so let's put that asymptote right away. Now I love this because somebody always says, which direction does this asymptote go? And I say, it's a vertical asymptote. And they ask again, what direction does that go? It's vertical. It's a vertical line. So we're going to where x equal to 4. And we're doing vertical asymptote. Right away, we can narrow the shape down. So at the beginning of this section, we looked at what kind of graphs have 0, 1, or 2 vertical asymptotes. So what do we call kinds of graphs that have no vertical asymptotes? Look on your flow charts, right in a box. That's speed bump. If it has 1 vertical asymptote. Nice. I have wings, but I took them down for the. Very nice. Who's your genie? Or I guess who's your master? It's not Sheriff Ranger over there.
What's with the hammer?
The Walking Dead.
So 0 vertical asymptote speed bump. 1 is volcano, and there's variations of volcano. So it could be the both on the top like this, could be both on the bottom, could be a piece on top bottom. We don't know yet, but we know this is some variation of volcano. So it's good to put the visual in your head right away. Okay, step number 2. And how do we find the horizontal? Not necessarily the squared thing, because we don't have squares in this one. The degree. What's the degree on the top? And what's the degree on the bottom? So that's degree over degree. So conclusion, 2 over imaginary 1, which is just 2. Again, this is a horizontal asymptote, which means it has to be a horizontal line. No, because it's horizontal. So horizontal lines are y equal. So on the top, the leading coefficient is 2. On the bottom, the leading coefficient is 1. So 2 divided by 1. So we took this guys here. Step number 3. Intercepts, do x first. Why did I drop the numerator or the denominator right away? Because you're going to multiply it over. It's going to become 0. So if you can see that, just jump straight to this. Offer of -1, I heard really, really quietly. And again, I like to write it as a point just to remind myself it's not an asymptote, it's just a point on the graph.
Sorry for the interruption. With the owner of the Cavalier vehicle that's burgundy with the license plate R13388,
y-intercept. Okay, so basically anything with a 0 is going to go away. Okay, so we're 0 and then a half. So what that tells us is we can draw this piece of the volcano because we know it's going to approach the asymptote, go through those 2 points, and come down towards the asymptote. So we got half the graph right away just with calculating steps 1, 2, and 3. What do we not have? The other piece. And this is where we need to use a test point because we don't know if it's down here on the bottom. Is it up here on the top? Is it over here? We don't know. So by picking an appropriate x value, we can sub it in, figure out where the point is, and then draw the other half. Appropriate means I need to pick an x value over here. There's no point subbing in -8, for example, because I already know where that value is. So appropriate means we need to know something in here. So pick an x value that's in this area. 8. Okay, so we're going back to the question. 2 times 8. 2 times 8 plus 2. And on the bottom, 8 minus 4. Can we reduce 18 on 4? Can we reduce 18 on 4? 9 over 2. And if we want that decimal value, again, that's a coordinate point, 8, 4.5. Did we have to pick 8? No, we could have picked 5, 6, 7, 9, anything in this area just to determine where the other piece is. So we know that it's 8 and 4.5. So where's the other piece of the volcano? The top. So it's got to come through that point, approach the vertical asymptote, and that point and approach the horizontal asymptote. That's what the test point is just pick a value where you need to know where the graph is, sub it in, plot the point. It's going to tell you where the other piece is. That's it. That's rational graphs. Do you see why we practice the pieces first? Because to try to do this all at the same time is so overwhelming. Okay, step 1. Bless you. Factor. What can we factor? Okay. Do you want to do anything on the bottom? Okay, so we had done this example earlier, and we know we kind of want to cancel it with this 4 minus x, but in order for them to be exactly the same, we need to factor out a -1. So if I do 4 divided by -1, -4, and I'm going to write it as the second term. And if I have -x divided by -1, and I'm going to write that as the first term. Why did I switch their order? Just so that they look exactly the same. Okay, so this is going to cancel, and I'm just going to throw that negative in front. What's the conclusion? We have a hole at how do we find where the hole is? So we know that it's 4 to the right, but how do we know how much up and down it is? Yep, so just like the test point, we're going to plug it back into the equation. Now we have some choice. I can plug it back into the original, I could plug it back into the pre-canceled form, or I could plug it here into the post-canceled form. Which of these is going to be the easiest calculation? The last one's going to be just the easiest to figure out. Offer of -7. Confirm. And again, this is going to be a point, so I like to write it as a coordinate. And because I'm visual, I always put a little hole in front of it because it just reminds me that that's a hole. Okay, it's not just a point on the graph. So we can plot that right away. We've got 4 and then -7. And we just draw it as an actual hole on the graph, so a little white open circle. Horizontal asymptotes are oblique. Offer of y cannot equal 0. Okay, so we got a little flow chart you're looking. Which one of these do we have? So it would be synthetic division, but here's a little trick with anything that has a hole, is you can actually go back to this to graph it, which is going to be way easier than trying to go back to the rational. So anytime something cancels, use the factored form at the end or the cancelled form at the end. What kind of graph is this? It's just a straight line, and I know all lines are straight. So let's graph this. Well, how do you graph a line? Well, we want to get rid of the brackets. So getting rid of the brackets gives us okay, how do we graph a line? Well, we start at b. What's the b value? -3. And then we're going to count. So what do we do with that hole? Well, we just ignore it. Just skip it. And we're going to join the line on either side. So although holes are a little bit more work because we got to find the y value, they cut out a lot of the oblique asymptotes because we can go right to the canceled form and just graph it. There's your first graph with hole. It's kind of exciting. Okie doke, step 1. You guys are not chatty today. Offer of x plus 4, x minus 2. Confirm. I can't even see Adam's face. It makes me laugh. Like, seriously, every time I look this way, I start to laugh. Holes or asymptotes? Rebecca, I don't have mine, even though I want to check it too, but I don't have it out. I don't even have it out in front of me. They are asymptotes. X cannot be. So right away, we know this is going to be a variation of what? Sad clown face. Horizontal asymptote. So what situation do we have? So we had 2 offers here. Debate it. Degree over degree. What's the conclusion with degree over degree? Coefficients. So y cannot be 1. Intercepts. Again, I like to write it as a coordinate to remind ourselves it's an actual coordinate. Now use some logic here. We don't need to calculate the y-intercept. Why? Because it's going to be exactly the same point, because y also equals 0. So whenever you get the origin as one of your answers, it's also going to be the other intercept. Okay, so we know it comes through this point, and it comes down towards the asymptote, but doesn't cross. The problem is we don't know where the other half is. We don't know if it's the mouth, like the parabola piece, or if it comes back up like the cubic. What do? Pick a test point. So pick something in this area. What's the easiest value in there to calculate? Probably -1. So on the top we have -1 squared. We have -1 squared. And on the bottom we have -1 squared. And then 2 times -1. Not J. Answer of -1/9. Okay, what's the coordinate point? Okay, someone wants to change this to a plus, so let's talk it out. So why did this 2 become negative? Because we're subbing in -1, so 2 times -1. Okay, so what's the coordinate points we're about to plot? -1, -1/9. If you make me do all the work, I'm going to start making 1,000 mistakes, so you're going to have to fix them all. Okay, so 1 minus 2. -1, -1 minus 8. -9. Okay, so -1 minus 1/9. Yeah, I mean, it's going to be close, right? So does it go back up like a cubic, or does it come back down like a parabola? Has to come back down like a parabola because that point is lower. Oh, you can cross horizontal asymptotes. Surprise! You just can't cross vertical. Because it's just the way that it works. Because there's parts that level off and parts that cross, and to explain to you which will take about 3 days. So just go with it. You can cross a horizontal asymptote. This is why I wanted to talk about them last year, but they were like, no, don't talk about them. It wouldn't come down, though, and then go back up. It would just swoop through, so it would never come down like that and back up. No, no, it's just going to swoop up, or swoop down, sorry. What do we still need? What do we not have? The 2 other sides. Well, we could do test points. Nothing wrong with that. Or we can use logic. If we have a mouth or the parabola piece, where do the eyes have to be? On the top. So we can just estimate them. We know they're going to approach the asymptotes. I don't know exactly where they're going to go through. The exam people don't care. They just want to know generally, do you have the right shape? If you want to be exact, pick test points and do them perfectly. Otherwise, we just know they're going to be opposite from the mouth. Do they have to be in red? No, because there's only one graph. I just always do last graph in red. I'm just trained. How are we feeling so far? Where are we on this? Good, okay. Ready to try one on your own or not yet? Nope, okay. Step 1. there is the offer. Confirm, not confirm. Like a really quiet confirmed on the other side. Just doesn't really sound confirmed. Waiting for like a yes confirm.
Yes, confirmed.
Okay, conclusion. Offer x cannot be -2. We can already start picturing the shape. One vertical asymptote tells us some kind of volcano. Could be a variation, could be a straight up volcano. Step number 2. Okay, so let's look at the degree. What do we have on the top? David, hat, please. Oh, we're doing another division. Okay, so what goes inside the division sign? Offer of 2, 5, -12. Where do those numbers come from? The top. Okay, what goes on the outside? Tell me where -2 came from. So the bottom equate it to 0 and solve. Okay, step 1. I think he meant to say -4.
Yeah. -1, or 1 comes down, times by -2, and then -14, but then we can just cross that.
Okay, so the first one drops down, and then we're always multiplying by the outside number. So -2 times 2, -4. Add vertically, so drop it down, becomes 1. Repeat, -2 times 1 is -2. Add it vertically, drop it down. Okay, this guy doesn't matter. These two matter because one is the M and one is the B. Yeah, we're not so fussy on that one. Either or we'd accept. Okay, how do we plot that? Well, how do we plot any line? Start at 1. And this time, instead of joining in a solid line, we're going to join in dotted line. Okay, so here's your first time drawing an oblique asymptote. Correct. We just, I don't know, we just aren't as fussy about the notation. I mean, mathematically we should, but I don't know, we just would take it either way. We can't be black and white on everything. We have to have a little bit of gray in math and science. A little teeny bit. Not too much, that's crazy. Okay, so we know this is volcano, we know we have an oblique asymptote, so we know we have two pieces of the graph. The problem is we don't know if they're here, so kind of horizontally from each other, or if they're here, kind of vertically from each other. We don't know where the pieces are. So what do we need to do? Test point. So let's pick a point over here. Give me any x value in this area. -3. What do we do with that value? And you can go back to original, or you can go back to the factored form, whichever one you like better. I'm going to go back to the original for no reason. So x squared first, so -3 squared times 2. 5 times -3, and then -12. And on the bottom, -3 plus 2. Okay, so on the top we have 18 minus 15. 3 minus 12. Kind of. -9, and then -9 divided by -1. 9. The non-auditory people just hated that. So we'll just repeat it. -3 squared is 9 times 2 is our 18. 5 times -3 is -15. -12 stays. On the bottom, -3 plus 2, -1. We combined the top, so 18 minus 15 is -3. Plus -12 gave us -9. -9 divided by -1 is 9. And again, I like to write it as a coordinate just so we remember what are we doing here, what's the point, what are we calculating. So we have -3 and way up here at 9. What does that tell us about the left-hand side of the graph? It follows, so it's going to follow the asymptotes and look not very volcano-y, but kind of volcano-y. Anything in this value. We just started on the left-hand side. We could have picked over here if we'd wanted to. Nope, you could have put -3, -4, -5, -6. We just picked a value. Well, we have to start somewhere on the graph, right? So I just said, let's start on the left. Well, if it's on the left here, it's never going to be up and down because they always go across from each other. So if this one is on the left, it means the other one's going to be on the right. So we could do a test point. We could pick 1 or 2 and test it. We're just going to mirror it. We know it's got to follow the asymptotes. If we had done a test point and it had been on the top, the other piece would have been on the bottom. They're always diagonal from each other. How are we feeling on that oblique asymptote? We're okay? I think it's time for you and a partner. I'm kind of feeling it. So do you want to offer the y value of the whole? Somebody want to confirm that? Oh, you can't see. So do you want to confirm? 0, okay. You're taking this and subbing into here.
Can't you just sub it into the last thing?
The factored form? Yeah, if you want to, absolutely.
It would just be into the x plus 3. Or you have to just.
No, well, you'd have 1 over x plus 3, right? Yeah, that's fine. Still just looking for confirmation. It's 0? Looking for confirmation of 0. Still looking for confirmation. Okay, I'm just going to draw that in pencil. So -1.5 and 0. I didn't get 0 either, but they confirmed it, so we'll go on from there. What about the vertical, or the horizontal?
Wait, I got a weird number. I got like. I got -4.125. I have no idea.
Okay, so there's all the offers so far.
2.3 repeating.
Sorry, what did you get, Chantal?
I get under 5. Like, okay, because that's -1.5. Are we putting this into, because it doesn't matter where we put this into, right? I got under.
No, I'm not showing you how to substitute into your calculator. No, we did that in grade 10, we've done that in grade 11, so you guys need to come to consensus.
Divided by 0. So it's undefined, so it's not.
Okay, so I put undefined as a possibility. Probably not a good strategy.
If you don't put it into the factor form, you can't.
Okay,
Why can't you?
Because that's for the horizontal aspect. That's for, what did you say that was? That's oblique?
I'm confused now.
no, there's no oblique here.
No.
Well, it's 1 over,
But that's what we use the factor for.
not for oblique.
We'll use that.
Okay, well, fight it out, because we got 1, 2, 3, 4, 5, 6, 7 answers now.
But what if it's undefined? That means that Oh boy.
Yeah, wouldn't it be
0.6 or 3. It's undefined.
So where do I draw an undefined? But I have to put a hole on the graph. The whole, just one big circle.
I like that idea.
This is when we just skip the question.
No, this is when we talk about the question. But is 0 the same as undefined? Okay. Okay, so let's try some other things. So these people that actually got numbers, how did you get numbers? Okay, so we're back to 0.
Okay, help us out.
I am. I'm prompting conversation.
Well, the first time that we did it, we put it back into the factored form, so it makes sense to do that again.
Okay, so when we did the whole example before, that's a really good one to look back to. What did we do?
We put the x value into the new factored one.
Okay, so I told you in that example, whenever you have a whole, because some of you had to write it down because I said it about 5 times. Some of you still aren't listening, so I'm just not going to repeat things now. I'm not listening. The last example with the whole, flip back. What did we write down? I said whenever there's a whole and something cancels. Maybe I'll repeat it because I didn't write it down the first time. Whenever you're dealing with a whole, then you work from the factored form. Because of course, if you put this back into the original, of course it's going to be undefined. We just said this is where x is undefined. Okay, so going back into this one, it's always going to give you undefined. Okay, so with every whole, you're going on to the factored form. But we still need to figure out which of these is correct from the factored form. And which one was yours? Because there was a lot of offers. 0.7, okay. Okay, we got an offer of 0. Two-thirds, so 0.66 repeating. Sorry, 0.5 I just heard.
I agree with that.
Well, it's like every time I type it in different, I get different.
Then that's not the calculator. That would be the operator.
Well, yeah, but yeah, just trying to figure out different stuff. Oh, I got 0.6 once, 4 times. Around there. I got Chantel's answer, but I also got 2.3 and a 2.8. And I got a 0.
Wait, so it's not 0?
I'm waiting for you guys to figure out.
It's 0.6 repeating.
I kind of feel like we have a 0.6 repeating confirmation.
Yup.
Okay, is it the same thing as 0.7?
No.
No. If you round to 1 decimal place, yes. But you didn't tell me that. Are we happy? Can I pen this and...
Love to do it.
If it's actually happening and we're confirming it, can someone explain how?
Okay, someone explain how they got it. So tell her what you punched into your calculator.
You go 1 divided by bracket.
Why, okay, why is it one though? Because these cancel out, so this is one. Oh. Oh my gosh, okay.
I'm still not sure we're confirmed.
The coordinate is -3 divided by 2.
Okay, so negative 1.5
Yes.
and positive.
Okay,
Up
yes.
0.6. How do you put so much distance? Is it like in between in the box?
Okay, we're committed. It's in pen. Whew, that was only step 1. Okay. I am not telling you. I am leaving this in your capable hands.
Why is it in the second box? Shouldn't it be in the third?
You want it in this one? Step 2. That one we like? that sounds very confirmed.
That one's a bit better.
X-intercept. But now we have conflicting y values for -3.5. There might not be, but I'm just worried about this. I just wrote down so we can have another offer.
We use the x-intercept, I mean, the factored forms, find the x-intercept.
We have to use the factored form.
Well, there are no X's. We have to use
I'm just you're telling me to write down. So I heard someone say 1 over.
then you gotta get rid of the x plus 3, so that's just 1 equals 0.
And what does that mean?
Means there are no x-intercepts.
Right, no x-intercepts. Which if you look at the graph, it's probably not going to cross that horizontal asymptote. Y-intercept. Hello, Mr. Shirk, you never come to visit. Where is your costume? You seriously need to be Shrek. That would be so funny.
That's never gonna happen.
So funny.
But I'm gonna put on the hallway Punisher.
Oh,
That
nice,
one
nice.
tap
Yeah.
dance number. I had to get my kids ready this morning. Have a good one.
That sounds confirmed? Okay, so tell me what this right-hand side's going to look like.
It's gonna be volcano.
It's going to be volcano, except it's just going to skip the hole. I'm sorry. I think that's kind of cool, a volcano with a hole in the middle of it. So there was a start of a couple of questions there. How do we know? That was my question. How do we know what to do on this side? We take a test. So is it up here? Okay, how do we know? Well, because there's no x-intercept, it can't cross the axis. Which point? There is no x-intercept, so we don't put an x-intercept. There isn't one. It's not going past the x-axis. The y-intercept we put right there. Yeah. Okay. How do we know what's going on over here? Is it up with the other volcano? Is it down here? How do we know? But volcano could be down here. Test point. Okay, pick a value. I heard -4. Where do we put the test point? Factored form. Confirm -4, -1. So tell me about the other half of the volcano. Can it cross that horizontal asymptote? How do we know? Because there's no x-intercept. Whew!